Hello all, എല്ലാവർക്കും പുതിയൊരു ക്ലാസ്സിലേക്ക് സ്വാഗതം. സോ ഇന്നത്തെ ക്ലാസ്സിൽ നമ്മൾ അടുത്ത ക്വസ്റ്റ്യൻസ് ആയ കഴിഞ്ഞ ക്ലാസ്സിൽ വരെ നമ്മൾ ഫസ്റ്റ് ടു 10 ക്വസ്റ്റ്യൻസ് ഡിസ്കസ് ചെയ്തു. ഇന്നത്തെ ക്ലാസ്സിൽ നെക്സ്റ്റ് 5 ക്വസ്റ്റ്യൻസ് ലൈക്ക് ഫ്രം ക്വസ്റ്റ്യൻ 11 to 15 ആണ് നമ്മൾ ഡിസ്കസ് ചെയ്യുന്നത്. സോ ഈ ക്വസ്റ്റ്യൻസ് ആർ MCQs ബട്ട് ഓഫ് 2 മാർക്സ് ഈച്ച്. കഴിഞ്ഞ ക്വസ്റ്റ്യൻസ് 1 to 10 നമ്മൾ ഓരോ ക്വസ്റ്റ്യനും 1 മാർക്ക് വരുന്ന ക്വസ്റ്റ്യൻസ് ആണ് ഡിസ്കസ് ചെയ്തത്. ഇന്ന് വരുന്ന 5 ക്വസ്റ്റ്യൻസ് ആർ ഓഫ് 2 മാർക്സ് ഈച്ച്. Okay, so the first question, this is of section A, and question 11 to question 30 carry 2 marks each. Okay, so the first question, the function f of x is equal to exponential sin x is expanded as a Taylor series in x around x is equal to 0. In the form f of x is equal to summation n equal to 0 to infinity a n x raised to n. The value of a0 plus a1 plus a2 is. Okay, so the function is f of x is equal to exponential sin x. The function is expanded as a Taylor series in x around x is equal to 0. Expand as Taylor series in x around x is equal to 0 means this is the Maclaurin series. Okay, around x is equal to 0 in the form f of x is equal to summation n is equal to 0 to infinity a n x raised to n. The value of a0 plus a1 plus a2 ആണ് ചോദിച്ചിട്ടുള്ളത്. So, equation a is the coefficient of x to the power n. So, a0 is equal to, or f of x can be written as a0 x raised to 0 plus a1 x raised to 1 plus a2 x square plus etc. Okay, this is equal to a0 plus a1 x plus a2 x square plus etc. So, question is a0 plus a1 plus a2 in the sum. That is a0, a1, a2 in the sum. So, a0, a1, a2 are the coefficients of the first 3 terms. Okay, so in Taylor series expansion, an is defined as nth derivative of the function at x is equal to a. But a or the point around which the function is expanded is 0. So, nth derivative of the function at x is equal to 0 divided by n factorial. That is the coefficient of the x raised to n terms. Okay, in general, in Taylor series, a function is expanded as summation n equal to 0 to infinity a n x raised to n. This is equal to summation n equal to 0 to infinity nth derivative of the point at x is equal to 0 divided by n factorial into x raised to n. So, these coefficients are a n. This is a0 plus a1 plus a2. So, first one, for n is equal to 0, a0 is equal to zeroth derivative of a at x is equal to 0 by n factorial. This is equal to zeroth derivative in the it is the function itself. Okay, so the given function is f of x is equal to exponential sin x. Okay, f of x is equal to exponential sin x. Okay, so the function value at x is equal to 0 is exponential sin 0 divided by 0 factorial. This is equal to sin 0 means sin 0 is equal to 0. Exponential 0 is equal to 1. Okay, now a1 for n is equal to 1. a1 is equal to first derivative of the function at x is equal to 0 divided by n factorial. Okay, so the first derivative of the function is equal to function exponential sin x. So the first derivative of the function is exponential sin x into cos x. And the function or a1 is equal to first derivative at x is equal to 0 by n factorial or 1 factorial. Here n is equal to 1, so 1 factorial. So first derivative at x is equal to 0 is exponential 0 into cos 0. This is equal to again 1. Okay, a1 is equal to 1. Now for n is equal to 2, a2 is equal to second derivative of the function at x is equal to 0 divided by n factorial. But n 2 by 2 factorial. Okay, and second derivative of the function is equal to f dash x is equal to exponential sin x into cos x. In this derivative exponential sin x into cos x or cos square x plus exponential sin x into cos x in the derivative is minus sin x. And at x is equal to 0, second derivative of the function is equal to exponential 0 into cos 0 is 1 into 1 plus exponential sin x again exponential 0 into sin x. Sin 0 is equal to 0. So again, the value of second derivative is equal to, at x is equal to 0 is equal to 1. Okay, so a2 is equal to second derivative at x is equal to 0 divided by 2 factorial, that is equal to 1 by 2. Okay, so നമ്മുടെ ക്വസ്റ്റ്യനിൽ ചോദിച്ചിട്ടുള്ളത് the value of a0 plus a1 plus a2. a0 നമുക്ക് കിട്ടിയിട്ടുള്ളത് 1, a1 is again 1, a2 is equal to 1 by 2. So this is equal to 1 plus 1 plus 1 by 2, and this is equal to 5 by 2. Okay, so the value of a0 plus a1 plus a2 of the Taylor series of the function exponential sin x around x is equal to 0 is 5 by 2. So the correct answer is option C, 5 by 2. Now the next question. Consider a unit circle C in the xy plane centered at the origin. The value of the integral over the closed curve sin x minus y dx minus sin y minus x dy over the circle C traversed anti-clockwise s. Okay, so consider the curve nu parayunnathu is a unit circle in the xy plane centered at the origin. Okay, so the curve is a unit circle in the xy plane centered at the origin. Okay, this is a unit circle. And the value of the integral over the closed curve sin x minus y dx minus sin y minus x dy. The value of this integral around the curve of unit circle centered at the origin ആണ് ചോദിച്ചിട്ടുള്ളത്. Okay, so നമുക്കറിയാം according to Green's theorem, this is of the form, this function is of the form m dx plus n dy. Okay, suppose this is m and this is n. This is integral over the closed curve m dx plus n dy. So according to Green's theorem, integral over the closed curve m dx plus n dy is equal to surface integral of del n by del x minus del m by del y dx dy. Okay, Green's theorem in a plane പറയുന്നത് integral over the closed curve of m dx plus n dy is equal to the surface integral of del n by del x minus del m by del y. Okay, so the equation number 1 നമ്മൾ m dx plus n dy ആയിട്ട് കമ്പയർ ചെയ്യുമ്പോൾ m is equal to sin x minus y and n is equal to minus, this is of the minus n dy, so x minus sin y. Okay, n is equal to x minus sin y. ഇനി നമ്മൾ ഗ്രീൻസ് തിയറം യൂസ് ചെയ്യുമ്പോൾ നമുക്ക് സർഫസ് ഇന്റഗ്രൽ വേണ്ടത് del n by del x minus del m by del y. So del m by del y is equal to differentiating m with respect to y is equal to minus 1 and differentiating n with respect to x is equal to 1. Okay, so Green's theorem വെച്ചിട്ട് sin x minus y dx minus sin y minus x dy can be written as surface integral or double integral of del n by del x. Del n by del x is 1 minus del m by del y. Del m by del y is minus 1. 1 minus minus 1 dx y. So minus minus becomes plus. This is equal to 2 into surface integral of dx dy. Okay, so നമ്മുടെ curve തന്നിട്ടുള്ളത് is a unit circle centered at the origin in the xy plane. Okay, so in xy plane dx dy is a unit circle. Okay, so xy plane dx dy എന്ന് പറയുന്ന area element is when theta is fixed. നമ്മൾ spherical polar coordinates എടുക്കുന്ന സമയത്ത് r theta phi theta is fixed. Xy plane means theta is the angle drawn from the z axis. So theta for in xy plane theta is equal to pi by 2 is fixed. So in an xy plane in spherical polar coordinates the area element in xy plane the spherical polar coordinates area element dx dy is given by r dr d phi. Okay, r dr d phi. So this is equal to 2 into integral r dr d phi. Integral r dr d phi. Okay, so this is a unit circle and the curve is a unit circle. So r varies from 0 to 1 and phi, the angle on the xy plane, or the angle phi varies from 0 to 2 pi. Okay, this is r is equal to, and this is phi. So നമ്മൾ integrate ചെയ്യുന്ന സമയത്ത് 2 into r നമ്മൾ integrate ചെയ്താൽ r square by 2 into 0 to the limit 1, and d phi integrate ചെയ്യുന്ന സമയത്ത് it is phi with the limits 0 to 2 pi. So this is equal to 2 into by 2 നമ്മൾ പുറത്തെടുക്കുന്ന സമയത്ത് again 1 ലിമിറ്റ്സ് ഇട്ട് കൊടുക്കും, r സ്ക്വയറിന് നമ്മൾ ലിമിറ്റ്സ് ഇട്ട് കൊടുക്കുമ്പോൾ 1 minus 0 into 5ക്ക് നമ്മൾ ലിമിറ്റ്സ് കൊടുക്കുമ്പോൾ 2 pi. So 2 cancels into 1 minus 0 into 2 pi. So നമ്മുടെ answer is 2 pi. Okay, the correct option is option B, 2 pi. The given equation in Green's theorem, according to Green's theorem, നമുക്ക് surface integral ലേക്ക് convert ചെയ്യാം. അങ്ങനെ നമ്മൾ convert ചെയ്തിട്ട് dx dy എന്ന് പറയുന്ന area element in spherical polar coordinates in the plane dx dy is equal to r dr d phi. Then നമ്മൾ limits കൊടുത്ത് integrate ചെയ്താൽ we will get the value of the integral is equal to 2 pi. Okay, the next question. The current through a series RL circuit subjected to a constant EMF E or epsilon obeys L di by dt plus IR is equal to epsilon. Let L is equal to 1 millihenry, R is equal to 1 kilo ohm, and epsilon is equal to 1 volt. The initial condition is I of 0 is equal to 0, and at t equal to 1 microsecond the current in MA is, in milliampere is. Okay, so നമുക്ക് ഇവിടെ ഒരു differential equation തന്നിട്ടുണ്ട്, and the values of L, R and epsilon തന്നിട്ടുണ്ട്. Initial condition also at t is equal to 0, the value of current is equal to 0. Then at t equal to 1 microsecond, the value of current in milliampere ആണ് ചോദിച്ചിട്ടുള്ളത്. So first നമുക്ക് differential equation solve ചെയ്യാം. The differential equation is L di by dt plus IR is equal to epsilon. Okay, or di by dt plus di by dt plus r by Li is equal to epsilon by L. Okay, this is of the form, this differential equation is of the form of linear differential equation, or dy by dx plus py is equal to q. So linear differential equation solve ചെയ്യാൻ വേണ്ടിയിട്ട് നമ്മൾ ചെയ്യുന്നത് integrating factor കണ്ടുപിടിച്ചിട്ട് then integrating factor കണ്ടുപിടിച്ചിട്ടാണ് നമ്മൾ solution ചെയ്യുന്നത്. So നമ്മൾ ഈ equation ആയിട്ട് compare ചെയ്യുന്ന സമയത്ത് p is equal to r by L and q is equal to epsilon by L. Okay, so the integrating factor in a linear differential equation is given by exponential integral p dx. This is equal to exponential integral p is equal to r by L. Okay, p is equal to r by L. And ഇവിടെ നമ്മളെ questionൽ the variable is t or time. So exponential integral p dt or integral r by L dt. Okay, this is equal to exponential r by L into t. This is the integrating factor. So linear differential equation il namukku integrating factor vechittu nammal solution, the solution of the equation, solution of a linear differential equation is given by y into integrating factor is equal to integral q into integrating factor dx plus c. Okay, ഇതായിട്ട് കമ്പയർ ചെയ്യുന്ന സമയത്ത് നമ്മളെ കേസിലെ സൊല്യൂഷൻ നമ്മൾ കണ്ടുപിടിക്കുന്നത് i ആണ്. So instead of y it is i into integrating factor is exponential r by L into t. This is equal to integral q എന്ന് പറയുന്നത് is epsilon by L into again integrating factor exponential r by L into t dt. Okay, ഇത് നമ്മൾ integrate ചെയ്താൽ this is epsilon by L exponential r by L t into r by L. So into divided by r by L or L by r plus c. Okay, I into exponential r by L t is equal to epsilon by L exponential r by L t into L by r plus c, where c is an arbitrary constant. So L cancels, so it's epsilon by r exponential r by L t. This നമുക്ക് തന്നിട്ടുള്ള initial condition is initial condition as I at t is equal to 0 is 0. So at t is equal to 0, at t equal to 0, I is 0. So left hand side becomes 0. This is equal to epsilon by r into exponential r by L into t. So when t is 0, exponential 0 plus c. Okay, which implies, so exponential 0 is 1, so which implies C is equal to minus epsilon by R. Okay, C is equal to minus epsilon by R. So are given, so the solution of the equation is I into exponential R by LT, I into exponential R by LT is equal to epsilon by R exponential R by LT plus C. Okay, plus C are our solution. So our initial condition vechittu we find C is equal to minus epsilon by R. So minus epsilon by R. Okay, so we given differential equation solution we kandupidichu. Ini choichittulladu the at t is equal to 1 microsecond the current in milliamperes. So at t is equal to 1 microsecond. And other values namukku thannittulladu L is equal to 1 millihenry, R is equal to 1 kilo ohm. L is equal to 1 millihenry, R is equal to 1 kilo ohm, and epsilon is equal to 1 volt. These constants we substitute at t equal to 1 microsecond, the value of current in milliampere. Okay, so I and I into exponential, the value of R is, or R by L we evaluate R by L into t. Okay, exponential power is R by L into t. So this is equal to R is 1 kilo ohm by L is 1 millihenry into 1 microsecond. Okay, so this milli and micro 10 raised to minus 3, or we can write. Okay, so this is equal to 10 raised to 3 into 10 raised to minus 6 by 10 raised to minus 3 ohm second per Henry, or it becomes 10 raised to minus 3 cancel, this become minus 3. Then the value of R by L into T is equal to 1. Okay, so exponential R by L T is equal to exponential 1. This is equal to epsilon is 1 volt divided by R. R is 1 kilo ohm into again exponential 1 minus epsilon is 1 divided by the value of resistance is 1 kilo ohm. Okay, so this is equal to E minus 1 by 1 kilo ohm, or 10 raised to 3 ohm. Okay, I into E is equal to E minus 1 by 10 raised to 3 ohm, which implies I is equal to E minus 1 by E. Then 10 raised to 3 numerator it becomes 10 raised to minus 3. Only this is ohm. Okay, 1 kilo ohm, 10 raised to 3. So E minus 1 by E into 10 raised to minus 3. So this is equal to E minus 1 by E into 10 raised to minus 3 is milli. Then the unit of current is ampere. Okay, so the value of the current in milliampere at t equal to 1 microsecond is E minus 1 by E. So we options compare we transform E by E is 1 minus 1 by E, or this can be written as 1 minus E to the power minus 1. Okay, so we options okay, the correct answer is option C. We get the form E minus 1 by E and we option answer convert we get 1 minus E to the power minus 1. So option C is correct. Now the next question, an ideal gas in equilibrium at temperature T expands isothermally to twice its initial volume. If delta S, delta U and delta F denote the changes in its entropy, internal energy and Helmholtz free energy respectively, then, okay, so an ideal gas at temperature T expands isothermally to twice its volume. Okay, suppose V1 to V2 anengile, or V2 to V expand another. Okay. An ideal gas in equilibrium at temperature T expands isothermally to twice its volume V. Okay, twice its volume. Suppose the initial volume is V, then the final volume is 2V. If delta S, delta U and delta F denote the changes in its entropy, internal energy and Helmholtz free energy. So, these changes in delta S, delta U, delta F values are whether positive and greater than 0 or whether equal to 0 or less than 0. Okay, so first it is given that isothermal expansion. Isothermal expansion ആണ് പറഞ്ഞിട്ടുണ്ട്, which implies dt is equal to 0. Isothermal expansion എന്ന് പറയുമ്പോൾ the temperature difference is 0. Okay, that is the expansion at constant temperature. So dt is equal to 0. dt equal to 0 implies du is equal to 0. Okay, change in temperature 0 anengil, the change in internal energy is also 0. So, or the delta U is equal to 0. So, we options nokkuna delta U 0 aayittulla two options and the first and last options we eliminate. Okay, now whether delta is greater than 0 or less than 0. Okay, so delta S is given by dq by t. The change in delta S is given by dq by t. Also, du is equal to dq minus dw. Okay, du, the change in internal energy is equal to dq minus dw. So, isothermal expansion dt equal to 0, also du is equal to 0. So, du is equal to 0, which implies dq is equal to dw. Okay, or the change in work is, the work done is p dv. Okay, so delta S can be written as p dv by t. Sorry, this is elementary change in the entropy ds is equal to p dv by dt. Okay, so the change in entropy delta S is given by integral p dv by t. For an ideal gas, PV is equal to nRT or P is equal to nRT by V. So, this substitution this is equal to nRT by V into T dV. And the integral and the volume changes from V1 to V2, or question is the isothermal expansion. In isothermal expansion, the volume changes from twice to its volume. Okay, twice to its initial volume. So, V changes to 2V. T cancel. So, this is equal to integral V to 2V NR constants dV by V. Okay, so the integral 1 by V dV is equal to log V, or NR log V to the limits V and 2V. This is equal to NR log 2V by V. V cancel. This is equal to NR log 2. Okay, so the delta S is equal to NR log 2, and both are positive constants. Log 2 is also positive, so this is greater than 0. Okay, so delta S is greater than 0. Delta S is greater than 0 option B aanu. For option C, delta S is less than 0. Now, we will Helmholtz free energy check. Okay, so Helmholtz free energy F is given by F is equal to U minus Ts. Okay, so dF is equal to du minus Tds minus SDT. Okay, the exact differential of F is equal to du minus Tds minus SDT. So, we isothermal expansion dt is equal to 0. Okay, so this term cancels. Also, du is equal to 0. Again, this term cancels. So, dF is equal to minus Tds, minus T into the change in the entropy. So, change in entropy delta S it is greater than 0. Okay, so this value is greater than 0. Okay, positive quantity into a negative quantity. So, the whole value minus Tds becomes less than 0. So, delta F is less than 0. Okay, so the correct option is option B. Entropy, the change in entropy delta S is greater than 0, the change in internal energy is equal to 0, and the change in Helmholtz free energy is less than 0 or negative. Okay, the next question. In a dilute gas, the number of molecules with free path length greater than or equal to x is given by n of x is equal to n0 exponential minus x by lambda, where n0 is the total number of molecules and lambda is the mean free path. The fraction of molecules with free path lengths between lambda and 2 lambdas. Okay, so n of x is equal to n0 exponential minus x by lambda number of molecules. Okay, the number of molecules with free path length greater than or equal to x. The question the fraction of molecules with the free path lengths between lambda and 2 lambdas. The fraction of molecules with the free path lengths between lambda and 2 lambda in fraction of molecules. Number of molecules is given by the expression n of x. Okay, so the fraction of molecules with the path lengths between lambda and 2 lambda എന്ന് പറയുമ്പോൾ lambda and 2 lambda path lengths വരുന്ന number of molecules divided by the total number of molecules. Total number of molecules means 0 to infinity വരെ mean free path വരുന്ന molecules. So this is the total number of molecules. ഈ fraction ആണ്, this is the fraction. ഈ fraction ആണ് ചോദിച്ചിട്ടുള്ളത്, the fraction of molecules with free path lengths between lambda and 2 lambda. Okay, so integral lambda to 2 lambda nx dx by integral 0 to infinity nx dx. So this is equal to integral lambda to 2 lambda nx is n0 exponential minus x by lambda dx. Okay, and divided by integral 0 to infinity n0 exponential minus x by lambda dx. So n0 are constants, so numerator denominator n0 cancel ചെയ്തു. This is equal to, now exponential minus x by lambda integrate ചെയ്താൽ again minus x by lambda into minus 1 by x square. So integral exponential minus x by lambda is equal to exponential minus x by lambda. With respect to x ആണ് നമ്മൾ integrate ചെയ്യുന്നത്. So this is equal to into divided by minus 1 by lambda. This is equal to minus okay. So this is equal to exponential minus x by lambda into 1 by lambda into minus 1 by lambda in the limits lambda to 2 lambda divided by exponential minus x by lambda in the limit 0 to infinity. Okay, so this is divided by minus 1 by lambda. This is equal to into lambda. Okay, so this is equal to നമ്മൾ ലിമിറ്റ്സ് പുട്ട് ചെയ്യുന്ന സമയത്ത് exponential minus 2 lambda by lambda minus exponential minus lambda by lambda. This lambda cancels. Okay, exponential in infinity പുട്ട് ചെയ്യുന്ന സമയത്ത് minus infinity minus exponential 0. Okay, this is my exponential minus 2 lambda limits exponential minus x by lambda il nammal lambda and 2 lambda limits put cheyumbo it is exponential minus 2 lambda by lambda minus exponential minus lambda by lambda divided by exponential minus infinity minus exponential 0. This is equal to lambda cancel, so exponential minus 2 minus exponential minus 1 divided by exponential minus infinity is 0 minus 1. Okay, or this can be written as exponential minus 1 minus exponential minus 2. This is 1 by e minus 1 by e square. Okay, so this is equal to e raised to minus 1 by minus e raised to minus 2 and this is equal to e minus 1 by e square. Okay, the integrate in some exponential minus x by lambda into integral into the term. Okay, sorry. Okay, so this is equal to exponential minus x by lambda into minus lambda and again here also into minus lambda. Okay, so nam limits put cheyumbom it is exponential minus, so minus into exponential 2 lambda by lambda minus exponential minus lambda divided by exponential minus 0 minus exponential 0. Okay, this is equal to exponential minus 2 minus exponential 1. this is equal to 1 by e square minus 1 by a, or this is equal to e minus 1 by e square. Okay, so the correct option is option D. Option D, e minus 1 by e square. Okay, so the fraction of molecules with free path lengths between lambda and 2 lambdas, e minus 1 by e square. Okay, so 3 questions are question number from 11 to 15, MCQs of 2 mark each. Thank you.